Hello and welcome to Math with Ms. V, Fundamental Counting Principle and Compound Probability. In previous videos, we have looked at how to build a sample space. And in this video, we will look at how we can find compound probability without having to create that sample space. We're focusing on standard 42 SP 8A, specifically the part where a compound event is the fraction of outcomes. So a compound event, as we learned in the previous video with sample spaces, are two or more simple events that happen. And the fundamental counting principle, which its definition is a little wordy, but it will make more sense when you see it in practice. If event M can occur in M ways, followed by event N that can occur in N ways, then event M followed by event N can occur in M times N ways. Now let's just break that down just a little bit to get started. Let's say our event M is flipping a coin, and we know that has two outcomes. And event N is a standard dice being rolled. We know that has 6 different outcomes. So what our fundamental counting principle is saying is that if we do M, so we flip a coin first, and then we roll our dice, we have 2 times 6 different possible outcomes, or 12. So using that idea, let's look at some examples. So we want to give the total possible outcomes using our fundamental counting principle and find the probability from tossing a coin and rolling a dice. So let's look at this first one, the probability of getting tails in an even number. Let's first start by using our fundamental counting principle. Which says if we take all the possible outcomes for the first event, so our first event is tossing a coin that has 2 outcomes, and we multiply it times all of the possible events of our second event, which is rolling a dice, a standard 6-sided one that has 6 outcomes, then we know we have a total of 12 possible outcomes. So how do we use that to find the probability of a certain event? Well, we take it in parts. So the first is the probability of getting tails. Well, I know from my coin there's 2 possible outcomes, and one of them is tails. Then I'm going to take that same idea from the fundamental counting principle and put my multiplication in. And for a number cube, I now have 6 possible outcomes. And even numbers, that's 3 of the 6. So I'm going to multiply and get 3 over 12. So there's my 12 possible outcomes, but I do have to reduce and get 1 out of 4. So there's 1 out of 4 chances of me flipping a coin and rolling a dice and getting tails and an even number. So let's find our fundamental counting principle for the next one. It's the same coin with 2 outcomes, the same dice with 6 outcomes, and so we'll have the same 12 possible outcomes. We want to know the chance of getting tails on our coin, that's 1 out of 2, times the chance of getting a multiple of 3. My multiples of 3 are 3, 6, 9, 12, etc. Only 2 of those are on a dice, so we're going to say 2 out of 6. I'm going to multiply and get 2 out of 12. Again, see my total possible outcomes is my denominator. We're going to simplify and get 1 out of 6. So I have a 1 out of 6 chance of getting tails and a multiple of 3. Okay, let's look at our next set of examples. We're using the numbers 1 through 5 and the letters in math. So the numbers 1 through 5, that's 5 possible numbers. My fundamental counting principle. We have 5 times the letters in math. There's 1, 2, 3, 4. 5 times 4. It tells us there's 20 possible outcomes for picking one number and one letter. Okay, now let's work in our 2 parts. So the probability of getting 3 is my number. Well, with the numbers 1 through 5, there's 1, 3 out of all 5 numbers. Now we're going to multiply it, the probability of getting M. Well, there's 4 letters in math. Only one of them is an M. You're going to multiply. 1 times 1 is 1. 5 times 4 is 20. So this is a 1 in 20 chance of happening. Okay. Again, we're dealing with the same situation. So my fundamental counting principle will still be 5 times 4, which gives me 20 outcomes. So this time we want a number less than 4. Okay, well, out of our 5 possible numbers, 1, 2, and 3 are all less than 4. So that's 3 out of 5. Then out of our 4 possible letters, we want the vowel, which is A. So that's 1 out of 4. I'm going to multiply and get 3 out of 20. So there's a 3 in 20 chance that I would get a number less than 4 with the letter A. Thank you for coming by this Math with Miss V video. I look forward to seeing you in a future one.